Right. Hello, everybody. Welcome to the call number 2 for the Interop working group. Uh, Thank you very much, everybody, for joining and for being active in the chat. It's been great. I know that, maybe we haven't had as much progress as we've liked over the past week or two, but I do think in a lot of ways things are continuing to move forward. And I know I've repeated this a bunch, but yeah, continuing to optimize for momentum, I think is really important. And I do think we're getting there. So I just wanted to encourage us all to not lose track of that, not lose track of how important it is that we deliver tangible value to users over these next few months, while not losing track of our long-term goals as well. And yeah, thank you everybody for keeping us all accountable towards that.
Whoa.
Cool. So jumping into the agenda, first up, updates from the chain-specific addresses group. Um, yeah, I'll start really quickly. I guess the TLDR from my perspective is that we've certainly spent a considerable amount of time going through the trade-off and design space here. I think we have enough information to make an informed decision. I would love, anyone else to jump in, share their thoughts from the group, or anyone that's outside of the group, of course. I would encourage anyone that's not fully up to speed to go through that group. I'll drop a link here in the chat, and I'll also, I should have done this previously, but I'll share a summary that I have. I'll drop that right after the call, so that we don't have to spend time on this call kind of rehashing things we've already discussed. But yes, we do have a separate Telegram group for chain-specific address discussion. And so I guess going forward, I think the most productive thing at this point is for us to, I think we can finalize this next week and do it async in chat. And yeah, so I've been having conversations with, we've been having conversations with all of the wallets. This includes MetaMask, all the L2s. Again, like very close, optimistic we can get this over the hump next week. Yeah, if anyone else from the group has things to add, please jump in right now. Otherwise, I guess I'd vote that we, sorry, someone's not muted. Otherwise, I guess, yeah, my vote, and happy to be overruled, of course, here, is that we keep maybe the rest of this async and move on to other topics, just in the interest of time here. But yeah, anyone else have anything they want to add on the topic of chain-specific addresses? Cool. Okay. Let's keep going then. Make sure everybody is muted, please. I'm getting a little bit of an echo. Cool. Updates from the message passing group.
Yeah, I'll just share a few slides that I put together really quickly. Okay, so here's a TLDR, what we've been discussing. So we did agree on the high-level goals of this ERC, which were the goals I presented during the last call. We are right now working on agreeing on a message format. And for all of this, we're using 7786 as the basis of our discussion. So right now we're talking about a message format that has attributes in it, like described in 7786. So that's kind of the lower level stuff that we're doing. The goal of this standard that we're working on is to, thank you to Francisco from Open Zeppelin for this, is we're standardizing application layer APIs to replicate the user and developer experience of same chain calls in the cross-chain setting. So that is our goal. Specifically, our goal is not to standardize a messaging protocol itself. It's just the APIs that devs will use. And I'm of the opinion that this ERC should work to cover 90% of use cases really well. And then edge cases can be handled by the messaging protocol itself. But 90% of use cases means, cross-chain function calls, bridging, etc. And it's not useful if this ERC is adopted, but then people have to put a bunch of wrapper contracts around it, because then kind of what's the use of a standard if people aren't really using the standard? So that's my quick TLDR of the message passing group. And then I also, in this message passing group, we had a lot of discussion kind of about the scope, like what are we achieving with this? So I put together just a brief set of my ideas about how this ERC and message passing relates to the goal of like having something within 3 to 6 months. So the end goal is that we want fast, trustless message passing between all of these different layers. And that is that's in opposition a little bit to users getting tangible benefits in 6 months, because a fast, trustless messaging protocol it's going to be hard for us to agree on. It's still like very new. So to get to the left side, we need to do things like standardize the data that's actually being proved on chain or across chains. We need to standardize the messaging interfaces. We need to standardize how L2s read L1 data, etc. All of these are super, super important, and we are going to continue to work on all of these things in the message passing group. However, it may be difficult to get real tangible benefit to users in the next 6 months doing these things. So I'm just going to propose something, which is that I think that adopting 7683 would be very good, because it seems like it's in a really good place where it can be adopted and implemented pretty quickly. And this is good because it will give users more liquidity, better swaps. It'll make the whole ecosystem work better within a very short time frame. And then obviously adopting chain specific addresses is what we're going to do as well. So I think that these are the two things that can make the biggest impact in 3 to 6 months. And then in the meantime, we should work on these other things. So I would like to get the message passing API ERC like decided on by the group within a month, so that we can start implementing these things. But I also know that it's going to take a while for certain projects to be able to implement these on mainnet, because it's quite an upgrade to their current protocol. So anyway, my proposal is just that we work on all of these things in parallel. Then we work on standardizing the data proved. And then finally, down the road, we'll work on standardizing the messaging protocol itself. I think all of this should definitely be able to be doable within this year. Like standardizing the messaging protocol should not be something that we're doing in like 2027. But yeah, basically TLDR of all of this is that we should work on these things in parallel. The message passing group will work on standardizing fetching L1 data, the messaging API, and the messaging protocol. I think a separate group should handle 7683 and getting that to mainnet. And obviously there's already a group for chain specific addresses. And yeah, so that's just my brief proposal there. Yeah, Ahmad. I'm not sure if you're talking, but you're muted.
Yeah, sorry about that. I wanted to say that I'm not sure about the reasoning behind standardizing reading L1 data. I think that each rollup should have its own way of reading L1 data, and that we shouldn't try to restrict it to a certain mechanism, because like we can see the innovation that's happening in the L2 space. There is multiple approaches to this particular thing, and yeah, like I think it should be more open. Is there any specific reasons for standardizing? So that's the first question. The second thing that I'd like to say about chain specific addresses, maybe I forgot to mention this before, but I wanted to make sure that whichever approach we have for chain specific addresses needs to make sure that we can specify chain specific addresses not only in wallet interfaces but also on chain. So we need to have a mechanism to like read those chain specific addresses on chain as well as on wallet interfaces. So if we're planning, for example, to use chain names or ENS names, we need to have a way to represent those in on chain. Yeah, that's all I wanted to say.
Yeah, so regarding the first point, we can certainly discuss this. I think that we should discuss it async in the message passing group. So if you're not already in that, DM me and I can make sure you're added. Because I think it's something that's a little bit further down the line anyway. I'll let Josh maybe comment on the second point.
Yeah, I guess the short answer is fully agree. Plans are in the works, and yeah, we should keep the conversation going on that point.
Yeah, and from my perspective, I don't know if Hart or someone from Across or Uniswap is on the call, but I don't know if you could give us an update, like how how quickly do you think that we could get something like that into mainnet across at least like a few different solver networks?
Yeah, Ellie, I think Zero Age is on here, and I think I saw Mark on here too. So I don't know, Zero Age, if you want to hop in too. But so 7683, I mean, it's the contracts are deployed and like reference implementations for solvers are being written. The part that I wanted to add, just to maybe share how I think this works with what you're working on, like 7786, I think these two things fit together like beautifully. Um, the mental model I have is you have like the intent as this kind of order ticket for your intention of what you want to do cross chain, and the settlement layer, which is escrowing user funds and validating that the intent was filled. It should use a message passing interface like 7786 to verify that intent, and then we can plug in whatever verification mechanism we want, be it storage proofs, ZK proofs, optimistic proofs, whatever,
Yeah.
in there. And so like that all fits together really, really nicely. Um, yeah. So yeah, I guess we're trucking on that.
Yeah. I don't know if Ed was first or Zero Age was first.
I think
Ed,
Zero
why don't
Age is first.
Oh, Zero Age, go ahead.
Cool. Yeah, first to weigh in on timelines, like when something like this would be ready to really get into production use on mainnet chains. It's a good open question, and I think that it'll continue to evolve from here. But I think that 3 months is a pretty good rough estimate of when we might start seeing systems that can leverage these standards come online and actually relay messages. I have 3 initial thoughts on the EIP on 7786 that maybe I just haven't read it closely enough at this point. But my first is that just working practically with push-based message passing, one of the most important things to determine before you're even able to send the message is how much is the message going to cost, right? And almost all message passing has some notion of like, all right, we're going to pay whoever's relaying this message, or even someone's going to have to pay to ingest the message and dispatch it or whatever. So some interface for quoting, right, of what's the estimate on how much this is going to cost, protocol fees or gas fees or whatever that means. Doesn't mean that every gateway would have to use it. It might not be easily something that you can just put on chain or even calculate, but having at least a standardized method that matches the same syntax, general syntax that tells you what you need to supply would be really useful in practice. Like a quote method.
If I can make
Oh, go ahead.
No, you finish.
The second thing is it seems as though this standard is mostly targeting push-based message passing, right? Where you are kicking off a message and then the message lands on the destination chain. There's a lot of really interesting pull-based, read-specific methodologies that are being designed right now, right? And some kind of unification or clarification around this might be useful. Maybe we just really hone in on this being for pushing messages and leave the pull-based stuff as more abstract, like as long as you have access to a state root, you can submit proofs, whatever. But it might be worthwhile to bundle these same principles and also specify like the interface on the receiving end, right? The outbox on the destination chain. And even in cases where there was no explicit message that went into a gateway or inbox, specifying this is the interface for receiving these messages, or even just pulling from arbitrary state roots or whatever. So that's the second thing. And then the third question is around if we want to specify some degree of substandards as part of this. Right now, there's a lot of heavy lifting in the data payload, and sort of just left up to the, like exercise for the reader. And I think there's going to be a lot happening in there. And I worry that if we standardize around, okay, you're using this interface to kick this off, and you specify the CAIP, and hopefully there's a way to derive what that maps to in an on-chain way. Now what, right? And so it will have 10 different gateways and 10 different data payloads that are all doing very similar things. So maybe we could work to standardize on a couple common use cases for messages that would be getting passed, and constrain that. Another thing that is, I think, generally important on that front that standardization could help with is when end users are signing payloads, that you want it to be structured, typed 712 data or something like that. Having standards on what they see gives users familiarity and enables us to build UI elements and improve the signing experience, right? And give more visibility. And signing an opaque data payload is not ideal, right? So granted, you can always encode it and map it back to what you need, but we should still try to standardize around what action would end users commonly be taking, or governance commonly be taking, that kind of thing, and standardize around that. Last thing I just realized that we should at least address at some point is aggregation. If you want to leverage multiple gateways, or some kind of redundancy in the way that you're passing messages for things that are really high security risk, or you just need additional confidence, maybe that's something we'd want to integrate into this standard, or at least have a footnote explaining how it would work. Anyway, that was a lot, but that's
Yeah, no, I appreciate that. Some of my just really quick reactions are that, so in my opinion, doing pull-based messaging can be on the messaging protocol level. It doesn't necessarily need to be into the dev API standard if that's not going to be important for most of the use cases. But we can discuss, and we in fact are discussing this in the other Telegram group. I would also suggest maybe we have an action item from this to like spin up a 7683 getting to production group that specifically is focused on that, because I think that work is very short term, and it's going to be separate from the general message passing dev APIs kind of work. And then around the substandards point, yes, I think I agree with this. We'll probably end up implementing these all of these messaging protocol standards in different chunks as we come to agree on them. Ed, I think you're next.
Yeah, please.
Thanks.
Please, before we go to Ed, I'm sorry. Can I give some element of answer for the previous question? Because as an author of 7786, I'd like to answer some of them.
that would be awesome.
Yeah. So for the first point, the reason we did not put, and this was mentioned quickly, but the reason we do not mention anything about the payment and the quoting part in 7786 is that this basically, yes, you need someone to pay for the operation to go through. but this doesn't have to happen on any particular chain. This payment could be settled on the origin chain, it could be settled on the destination chain, it could even be settled on a third-party chain that has nothing to do with it, or it could even be settled off-chain, like through some kind of Visa payment or something like that. So while I certainly agree that this part of like you need to have to pay for the message going through the network should be standardized, it's something that is, in my opinion, completely orthogonal from the message being sent and being received. And that's why it's, in our opinion, out of scope of 7786. So that was the first thing I wanted to say. For your second point, which was push versus pulled, we think about that a lot. The thing is that we don't find any example of pull-based model where what is being pulled wasn't somehow pushed before. Like the data that you want to prove on the other end, like I've never seen any case where what you're proving is some storage slot containing some storage some value, because like knowing which storage slot to look for is unrealistic. And usually what you are trying to prove is some event being emitted or something like that. But the emission of the event could be seen as data being placed for it to be fetched by a different chain. So that's why we feel that even in what is usually qualified as pull model, the data that is being pulled was somehow placed here. That's why we feel that a push model is simple and works fine. Maybe people will have counter argument and counter example, and we'd love to hear about that. In any way, like it could also be the case that a push-based model works in most cases, and an additional standardization effort should be done with pull model. I'm not sure. I mean, the goal is also we don't want the standard to be too big. And there was a third point that was about the format of the message. The idea with 7786 is to implement something that is similar to a call, like a contract calling another contract, like Uniswap calling an ERC20 contract, for example. And we want that to be an application thing, not an end user. So we don't think 7786 is something that would be used for, let's say, an EOA to call something on another chain. The goal is that it allows for pair of contract to communicate between, for example, a governor and some kind of executor that would be on another layer. And therefore, like the idea is that we just want them to be able to pass arbitrary data, and that data format, like each pair of contract that communicate to the bridge, in my opinion, should be able to set their own format of their data, regardless of the bridge they're using, and the bridge should not try to introspect this data and read it. So that's where, like, I think you mentioned things like EIP 712. I'm not sure it's really relevant here. Those were my answer. Thank you.
Yeah, I think this would be a really good discussion to have in the Telegram group, just because I know we want to get to other topics today. So anyway, but Ed, go ahead. Oh, I think you're muted, Ed.
Thanks. Yeah, I just have a question about sort of the expectations for this. You said that it's a goal to be both trustless and fast, which both of those are great. The question is, how fast is fast? In a setting where it's trustless, is the expectation that fast means about the speed of L1 block time, or does fast mean faster than L1 block time?
Yeah, this is a good question, and I think we're open to discussion because I think people have different opinions. I believe Mark Tyneway at the Interop forum proposed that you should be able to do bridging within 3 slots or less. I'm not sure if he was referring to OP slots or L1 slots. In my opinion, the bare minimum is for fast message passing to be on the order of 12 seconds for L1 block time. That's the bare minimum, and then we should improve from there.
Okay, thanks.
Yeah. Oh, sorry, Vitalik said that. I'm sorry.
Cool.
All right. Any other comments about kind of message passing roadmap and plans? If not, I'll hand it back to Josh.
Thanks so much, Ellie. Cool. If nothing else on there, we can move on to the next agenda item. We have about 30 minutes left and 3 items, so we'll be a little bit tight, but I think we can get through it all. 1 second, sorry. Okay, sorry. Next up, I wanted to share just a brief high-level proposal for how we can better organize the efforts in our working group. So this is sort of a process thing. Yeah, how can we better organize discussions over the next 3 months? I definitely don't want to bike shed on like optimizing the process, but also, in my opinion, clearly we do need some lightweight process to help guide us. So the goal is still to accelerate, but to do so in the most effective way possible, where we land not just on a suboptimal local maxima, but the correct solution for Ethereum. So I've been working with a few folks on this, and the awesome folks over at Wonderland who have kindly offered to dedicate some resources to helping accelerate and do some of the nitty-gritty work that we all know needs to get done, but is just tricky to find the bandwidth for. Of course, again, it's important that we balance this acceleration with making sure we get the proper inputs here, but confident we can find the right balance and push things forward together. So I just wanted to share that note before I got into sort of how we're thinking about organizing things over the next 3 months. Again, this is just sort of very high level. Anyone, jump in if, there's thoughts. So yeah, I guess with all that said, I can hand it over to the Wonderland guys who have a little, we can share a presentation on this.
Yeah, thanks, Josh. Okay, let me share my screen. Let me know if you're able to see this.
Yep, perfect.
Awesome. Okay, so as Josh was mentioning, there are a lot of efforts currently ongoing. There is a lot of excitement, right, to get shit done and to get the right shit shipped as fast as possible to bring users a lot of value. We've been sort of lacking for the past few months regarding this. So we get that. There's a lot of interest in this. We just need a little bit of alignment, pun intended, and also kind of checking into a more kind of organized way to collaborate, right? Like, let's move into what we know. There is already a lot of effort put on like open software development and collaboration. Let's use that rather than just throw a shit ton of messages on a Telegram group. So put together, we all know that not just L2s, but the entire ecosystem is not actually ready to interoperate today, right? If we had the perfect APIs, the perfect standards and everything ready, it will also take a lot of time for people to integrate this and to ship this into production safely for then users to use. And there is also education that needs to happen and a lot of things. So this is something that we need to accelerate on, but we need to accelerate on into the right direction and not generate like more confusion or kind of strand us in local maximas, as Josh was saying, but kind of try to figure out the best possible way or path into this. So there are a lot of efforts, as you already know. I think we all are on the same page on what we want to do and why. But I think we are lacking some common language and some kind of clear understandings regarding this. But it's something that is very easy to solve, and I'm very optimistic that we can do this in a very short time span. Okay, so shipping interoperability. So we have this quarter 1 plus 1 month. How? Very easy. We should move to having our conversations in GitHubs, like moving everything into a kind of a forum or GitHub issues or PRs or whatever type of collaboration platform. We can still keep using Telegram for async, Discord if we want to have the ETH R&D server as well. We can do these calls. This is awesome. We should continue to be as public as possible. Sometimes Telegram might be a mess. For new people to jump into GitHub is way easier, and it allows us to kind of pinpoint specific things. We should document a lot of the things that we're doing. This is an effort that we'll do the first month. So we'll gather as much information as we can. We'll digest that information and we'll present those into GitHub PRs, just so we can continue the conversation about specific topics there and not get kind of confused or entangled into other conversations or experimentations. I mean, avoid duplication of work. We honestly, I think we've been repeating the same things over and over for the past weeks. This should also just go into some place that we can just point people to whenever we are discussing these things again or whenever these things pop up. And as I said, like this should be similar to a development effort, right? We are building something for builders and users, and we should kind of use the same processes that we've been doing. And one of the most important points is also like we need to build first the foundations. I know that there is a lot of kind of experimentation and crazy ideas and improvements that we can do for the current state of interoperability. But if we did them, then you'll end up at the same problem that we have today, which is, okay, how do protocols and users interact with this? And you will just create a new API, and then we will have yet another protocol that we'll need to support. So that's not ideal. Okay, so starting from next month, just in a few days, as I said, we standardize the standards, compare them, kind of prime all the information to get conversation flowing into the right direction. We'll kind of make the nomenclature or the naming of things its own separate thing. Like we know naming is very, very hard. One of the toughest jobs of every developer. We don't give a fuck about that. Let's just do that separately. As I said, categorized efforts, and we'll focus mostly on primitives and properties of the systems. This is extremely important. Right now, most of the documents I've seen don't necessarily include the primitives and the properties of the system that they are describing. They just kind of describe a system and that's it. And you need to infer the properties or the primitives that this system is based on or is trying to achieve. This is a key part of being able to kind of compare and start building on top of these things and just discuss about, hey, is this breaking any of the primitives or the invariants that we designed the system for? Do we agree on these invariants or not? That's a very, very technical discussion, and we can, let's say, circumvent a lot of the chit chat around other things if we do this. For March, ideally, we can get a single first draft for every category. I think this is very doable. We do have a lot of information, as I said already, by a lot of great people from great teams. As I said as well, like we should just focus on the things that are must-haves. I know there is a lot of creativity going around, but I think we should just create a system that allows us to abstract away all these kind of nice-to-haves or crazy ideas and just give them just create a system that enables those things to happen, but just for now focus on kind of only the core aspects of what we're trying to build. We will start drafting a demo contracts and UI, a user interface for these efforts. This should be very, very simple, honestly. Ideally, we get collaboration from a wallet provider if they want to. Else, we just use like a burner account or an account abstraction contract on the UI itself. So it doesn't matter. And then ideally, we can start the draft review process of the draft that we created. April, our last month. So we get these draft reviews, we create the ERCs, or let's say ERC drafts. We launch the demo, we gather feedback on that. Ideally, we polish, fix, and change if there's anything that broke or that we fucked up. And the things that we need to make sure here is that experimentation here plays a key role because we need two things. We need to make sure that the current standard doesn't break existing protocols or doesn't, let's say, kind of doesn't basically disable existing protocols to integrate this standard. Let's say missing a feature, a key feature, or whatever. And more importantly, we need to make sure that all the experimentation and crazy ideas that you guys have do have a place in this new standard. Things that we need to avoid, custom implementations, they suck. Like the standards, and I guess we've seen some discussion on this call around these. Standards are not necessarily implementations. They are just specs. So we shouldn't be enshrining any specific implementation into the standards that we build. The demo is just going to be an example for people to grab and to also experiment on and adapt as they see it fit. Naming bike shading as well. Like, this is a pain in the ass. Let's just not get hung up on naming things. There are not going to be any, let's say, protocol specific or partner specific flavored specs. Obviously, we're trying to build this as generic as possible. We should avoid kind of having the user or the app developers handle a lot of the complexity. Complexity should be hidden away. It should be handled either by the standard or by the protocols, which do have the technical expertise to do this. One of the things 0h said, which was extremely important, is that payloads should be easily seen and analyzed, right? Currently, we were not thinking about this, and this is an extremely important point, because we were thinking, for example, 77086 is aimed at protocol developers. It's not aimed at users. It's an improvement for protocol developers to not have them build more wrappers for other things, etc., etc. So, okay, you just build and integrate 77086, and that's it, right? But the thing is, users don't care about that, and that's not the standard that we're trying to build. We're trying to build a standard for everybody, and ideally being focused on user and integrators, which are the ones that are going to literally create the adoption for this. Then to experimentation, as you've seen on the Telegram group, if you're there, like, there is a lot of things that we can build on top of this. There was discussion around, like, how do we rebalance like the money flying around? How do we integrate intents? As Hart was saying, like, intents work right now, they can be shipped, but the cool thing is, how do we ship them using the shared standard? So anybody, like any new wallet, any new dApp or whatever, can just say, hey, I'm using the Interop standard, so I get intents for free because they use the standard. So that's the end goal. It's not a good thing, and maybe we're like literally shooting ourselves in the foot if we are going to rush implementing intents, and then we're going to say, oh, by the way, now you need to also implement this new Interop standard that also implements intents, and then we also have to go and say, okay, intents now change whatever to support this new Interop standard. So that's not the way forward, in my opinion. We also talked about the kind of multi-sig of bridges and out of N bridges. Like, everything here should be possible. So pretty straightforward. The end goal here is, as we all know, we just want people to use Ethereum, right? We just want people to use what we are building as fast and as cheap as possible. And we just want developers to be able to build on top of these things as fast and as cheap as possible. And one of the most important aspects of creating a standard is also that the distribution that you get when building on top of a standard is massive, right? When you build an ERC20, you get AMMs, you get wallets supporting and displaying your balance. You get, I know, the ledger thing is saying, hey, you're transferring this token, and it shows like the symbol and everything. If you build a non-standard ERC20, like a non-standard token, you don't get that. And this is exactly what happens with messaging protocols right now. You're building a messaging protocol that does whatever, right, from here. You won't get shit. Like, wallets won't support you, L2s won't support you, users will literally don't know how to interact with you. So that's the pain that we're trying to solve. And that's it. Thanks.
Thanks, Kelly. Just one quick note, I guess, before we move on, and if anyone else has things, but yeah, open invitation to anyone else in the group for folks who do have interest to jump into more, I guess, what I'll call sort of the back end logistics heavy things. Yes, myself at the EF, others on the call here, Nicholas and others at the EF are dedicating more and more, I guess I'll say all of our time on this going forward, but do want to also find the right balance to making this a collaborative effort, of course. And, you know, this is where Wonderland and others are coming in. So, yeah, would love to make sure that anyone else who wants to get involved in these things that we just went through is able to do so. Yeah, Nicholas.
Yeah, quick message to say, on the first slide, I think you were mentioning posting messages on Telegram and versus GitHub, and we have like kind of a Cambrian explosion of Telegram groups in the last few weeks. So like, just quick message, the best way to use those Telegram groups is to have like quick chats, and whatever is really important and really makes the conversation move forward, you should try to post it on GitHub, because this is where things are moving. And tomorrow in the next ACD, I will introduce a bot that basically cross-post everything to Ethereum Magician. So like every call that we have like this will be automatically posted on ETH Magician, and you will have summary, and like you can take it from there. Eventually in the future, we can build on top of this, and we will have like AI tooling that will help us dig faster in the information. So yeah, keep in mind to like be as like ephemeral as possible on Telegram and as persistent as possible on GitHub. That's
PG.
Am I unmuted? I just want to say that this is actually my first time attending this call. So what we were just saying with the Wonderland section here, like at Polygon, we have people who are doing every single one of these pieces for Egg Layer right now. And I think what my goal is, because I am personally swamped, is to kind of bring those resources out here into the public a little bit more so that they have a chance to interact with everybody. I think that there's probably pieces of this that we can really help support, both like logistically, financially, and brain power wise, because our goal is also to like create this same world here. So what it would be really useful for me is to make sure that we have a section on these calls, at least occasionally, where we're highlighting places where resources are needed, so that I can kind of identify those at a high level and make sure that I'm just bringing in the right people from our team, because it's like not always my brain that's able to do the thinking about these pieces.
Yeah, great point. Agreed. And I will, yeah, follow up with you on that and make sure that we do have this going forward. Cool. Thanks, PG. Anything else, or we can move on to the next agenda item? Cool. Next up, RIP 7859, Ian from Polymer.
Hey, everybody, can you hear me?
We can.
Cool. Oh, thanks, Josh. So this RIP is really just born out of a desire for all rollups to provide a view of inside their execution environment of the L1 block that they are building L2 blocks off of. And the motivation here is that this unlocks a lot of capabilities that we're all familiar with. It allows you to verify arbitrary claims about the L1 inside the L2. And it also lets you, for example, when you're doing cross-chain transactions between two different rollups, make sure that the two rollups are building off of the same L1 history, so that if the L1 does fork underneath one of them, it'll fork underneath both of them, and they both can reorg together. So originally this started out really as just like an informal call to get every L2 to implement EIP 4788 as it is. EIP 4788 is a precompiled contract that stores beacon block roots and a ring buffer. And these can, of course, be used to verify arbitrary claims about L1 execution blocks as well. But this is actually pretty expensive and pretty clunky to generate these SSC Merkle proofs. So then it evolved into using sort of a modified ring buffer that instead stores a hash of a subset of the execution, L1 execution headers, so that you don't have to provide the entire execution header as a pre-image in order to access the fields that you're interested in accessing and using, to also reduce gas costs. But then after getting some feedback from Timeway from OP Labs, it's been reformatted to instead just standardize a set of interfaces, a contract interface for exposing information about the L1 origin, which is the L1 block that the L2 is currently building off of, without specifying any underlying implementation. Although it does also specify some invariants about what does L1 origin mean, what qualifies as a valid L1 origin. So yesterday in the chat, Vitalik made some really good points that, if you have L1 S load and it's an L1 S load implemented such that verification is deferred to settlement time, so you don't actually have to prove every access in the VM, then that provides a much more efficient access to L1 storage reads. And I completely agree. If you have L1 S load, then you would not use this proposal to verify L1 storage reads. But this proposal is more general purpose, and it provides some capabilities that you can't get out of L1 S load. In particular, it can be used to verify claims about state accounts, receipts and logs, and transactions in addition to storage slots. The way that it's proposed here, it could also be used to verify claims about historic L1 data, not just the current L1 origin. So it specifies, similar to EIP 4788, it specifies retaining some number of historic versions of the L1 state. And it can also be used again to perform these cross rollup consistency checks to make sure that the two rollups are actually building off of the same Ethereum fork, which you can't do with L1 S load. You need a top level commitment that you can compare. The storage value is not going to tell you what Ethereum fork you're building off of. And then another thing, which I think it would be good to get some input from some of the larger rollup builders on, is that I don't think L1 S load, at least with deferred, actually either way you implement it, it's not going to be able to operate if the L2 sequencer loses connectivity with the L1. And in OP Stack, for example, one of the reasons why they have this max sequencer drift parameter, which is basically like how much the timestamp of your L2 block can drift away from the L1 timestamp. One of the reasons they have this is so that even if the sequencer loses connectivity to the L1, to an L1 node, it can still continue building blocks for this amount of time in sort of this like detached state, which would not be possible with L1 S load. Any transaction that had L1 S load, which required reading from an L1 node, would not be able to execute, and when the sequencer is operating in this detached state. So I think that is potentially another difference here. So yeah, I think those are the main differences I want to highlight. And again, really the goal here isn't even really to get like this specific RAP accepted or included or implemented or whatever. It's really just for us to agree that we need to have some view of the L1 inside of the L2 execution environment, because it unlocks a lot of different capabilities, and it's really just such a low level primitive that personally it was really surprising when I figured out that like OP Stack and Scroll, I think, are the only ones that do it. Maybe I'm wrong. But yeah, I guess that's the pitch, and would be great to get feedback from people on this call.
Thanks, Ian. Feedback, questions? Yep, Ed.
Yeah, a couple things. One is it would be useful to, in an RIP here, to define what is supposed to happen on an L3 chain, right? Because there are plenty of those. And so, yeah, and I'm not sure what the right answer is, but I think it's useful to think about that.
Yeah.
Another one is that in the document as it is now, there's this notion of an L2 block being derived from an L1 block. And the way that works in many rollups at the time is such that when the L2 block is made, there is not yet an L1 block that it's derived from. So I can clarify that a little bit. So if the L2 sequencer sequences a block at time t, at some time later, let's say t plus 30 seconds, that the input to that block will get batch posted onto L1, right? And so the block in which that input is recorded on L1 does not exist at the time that the sequencer sequences the block. And yet you want it to be the case that the full contents of the block can be computed at that time. So even though it's true eventually that the block will be derived from L1, the contents of the block need to be independent of that because that block doesn't exist when the L2 block is sequenced. So I think talking in terms of the L2 having a view of some recent L1 block makes a lot of sense. And I think this is true in OP stack as well as Arbitrum, that when a block is sequenced, the L1 block that it will eventually be recorded in doesn't yet have a known hash.
Completely agree. And that may have just been a miscommunication. And
yeah, I think so. Could be. Yeah, the notion, I mean, I think the notion of having visibility into a set of L1 execution hashes makes a lot of sense on L2.
Yeah. Would you agree that so necessarily any nascent L2 block that's being built, you have to be considering deposits in the L1 contract? And so the goal here was really for whatever L1 block hash that you were currently considering for deposits in order to contribute.
There's some notion of what is the most recent L1 block that's visible to the L2 at that time.
So I would, if you have ideas about how to better word that, that would be great.
Yeah, great. Let's connect offline.
Thanks. Oh, sorry, I'm just now seeing this message. So I haven't really given that a whole lot of thought, but ultimately the correctness of this mapping needs to be enforced at settlement time, similar to how like the L1S load reads could be enforced at settlement time. It gets baked into your chain derivation logic, which is part of your fault proof program logic, which is embedded in the L1, or the ZK circuit, which is embedded in the L1 and verifies outputs at settlement time. And so at that point is when the correct mapping is actually enforced. I don't know if that completely answers your question, though.
Cool. Well, thank you, Ian.
Yeah, no problem. Proto, was this a question? Sorry.
I'm just clarifying the wording that the OpenStack uses. So,
Thank you.
Yes.
I think this is sort of the same point that we were discussing in response to my question.
Got it. Yeah, I'll definitely improve on this. Thanks.
Cool. Thanks, guys. Last up on the agenda, we have Derek from Rion.
Hey, thanks, Josh. Hey, everyone. Amazing meeting so far. I hope I don't change this. I'm going to share my screen. So at Rion, you probably know us better as Wallet Connect. We recently rebranded from Wallet Connect to Rion, and we have a wallet SDK mainly and an app SDK. And we've also done a bunch of standards before. And what I'm going to show now is it's a little bit downstream of everything that's been discussed here. Basically, in our wallet SDK, we wanted to make it easier for wallets to actually consume bridging and provide bridging to end users, basically with the goal that the end user just sees one aggregated balance and can just use that across all networks. And we wanted to build that in a way that it also supports EUAs and all types of accounts. So, and taking some trade-offs where maybe that's not the fastest latency compared to some resource locking approaches. But without further ado, I'll share my screen and then you can take a look. All right, I recorded this earlier today. Can everyone see the screen?
Yep.
Take that as a yes. So on the right side, you see a sample dApp. And what we built works both with in-wallet apps like a send button, where shortly we also support cross-chain addresses. But in this case, I'm going to use a more difficult scenario where you're actually using an external app. I'm also going to get to a new standard that we cooked up to support that. So on the right side is our sample app. It's a donut shop where you can buy digital donuts. In the middle, you can see our Swift sample wallet. So our wallet SDK is in all mobile wallets. So we have SDKs in all relevant programming languages. This one is the sample wallet for Swift. And on the left side, you can see my portfolio. What's noteworthy is that I don't have enough assets to actually buy this many donuts. I want to buy 6 donuts on Base, but I only have 3 USDC on Base, and 1 donut costs 1 USDC. So let's see what happens. I'm just going to click a button here. Okay, I'm clicking the checkout button. All right, and now you can see a little loading spinner in the sample wallet, and a UI pops up, and basically it tells me that as part of this, you're going to bridge funds. In this case, I'm bridging funds from Arbitrum. Behind the scenes in this scenario, this is using a cross. I know Hart is also on the call, so giving you a shout out. And takes a couple of seconds. And now it's done. So some other features this thing can do is it can actually source from multiple source networks, and then currently just bridges to the target network. And so, yeah, it supports multiple source networks. It can also abstract stablecoins. So in another example, I'm checking out in USDC, but I only have USDT on my wallet. And yeah, it's pretty cool. Another thing I want to highlight is the ERC 7811 standard that this app is using. The ERC 7811 standard addresses the problem that currently apps like Uniswap, and I know OXH is on the call, actually block the UI if you don't have enough funds on the target network. So basically, ERC 7811, the wallet get assets standard, is a solution such that the app can discover that the user actually has more funds on other networks, and hence you can actually fulfill the request. So we've released the wallet SDK of this about a month ago. Currently, there's our wallet SDK, as I mentioned, is in all the wallets. And yeah, currently there's 2 top wallets that are integrating the solution. And yeah, I wanted to share this here. I'm looking for feedback and people who want to collaborate on the app side 7811 standard. Also looking for feedback on this technical approach, or can dive a little bit deeper into this, what we have right now, and how we want to improve the latency in the future. So yeah, thanks for checking it out.
Thanks, Derek. And yeah, thank you for squeezing that in quickly at the end of this call here. I do want to be respectful of time. If anyone wants to keep chatting about this with you, where's the best place for them to find you? You want me to drop your Telegram in the chat here?
I'll put my Telegram in the chat. I don't use Zoom so often, but I think I found the, yeah, there we go.
Cool. So anyone follow up with Derek directly? And yeah, we can end there. Awesome. Thanks, everybody. Talk to you.
Thanks,
all.
Josh.
Yep.
Thanks, Josh.
Thank you.
See y'all. Thanks so much.
Please just drop it